Hello, welcome to another session of Thinking and Working Scientifically. Today, we are looking at energy and we are considering energy conservation and transformation. As always, let's start thinking. Why was light the very first creation before anything could take form in the universe? Have you ever thought about it? That light was the very first thing created? The answer is simple. It's about energy. Energy makes up everything in life, from plants growing, the wind, animals' growth, and everything there is in the universe, living and non-living, is made of energy. Without energy, nothing would exist. So the question then is, what is energy? Look at this. The car is moving. The big guy with book on his head. Look at the heart pumping. Look at the fan rotating. And the big guy at the right, maybe going to work. Who knows? Do you know what? They are all working. So whatever has the ability to work has energy. So the answer is simple. Energy is the ability to do work. Now that we know what energy is, do you know that there are two basic types of energy? I repeat, there are two basic types of energy. These are the kinetic energy and the potential energy. Kinetic energy is energy in motion, while potential energy is energy stored or at a point. Look closely. You would see everything here is having a form of motion. So whatever has a form or any form of motion has kinetic energy. And any form of energy that can move or be transferred is classified as kinetic energy, while any form of energy that can be stored or remains at a point is known as potential energy. So there are basically two types of energy: kinetic energy and potential energy. Take notes. However, there are different forms of energy, okay? There are different forms of energy. So there is this difference between the types of energy and the forms of energy. There are two types of energy, which are the kinetic energy and the potential energy. But under these types of energy, we have different forms of energy. So let's start with the kinetic energy. We have the mechanical energy. You can see the rotating fan. We have the magnetic energy. You can see the magnetic lines of force and you can see the movement there. We have the electrical energy. You can see electricity flowing through the wire to cause the light bulb to glow. We have the sound energy. You can see sound energy, sound wave going out of the speaker, moving out. We have the light energy. Turn on the light bulb, it flows down to your eyes, so it moves. Beautiful. And we have the heat energy. You touch a hot object, you feel heat transferred from where the heat is, it transmits through the object to your hand, or in the room, you find heat being transferred from your stove or from your electric iron, from your refrigerator to you. So any form of energy that can move, okay, is classified under kinetic energy. So let's look at potential energy, energy forms that are stored. These include the gravitational potential energy. We have the electric potential energy, like what you have with lightning. Do you know that lightning and thunder, as a result of electric potential energy, static electricity? Oh yeah, so electric potential energy is a form of energy. It is different from the electric energy, which is a form of the kinetic energy. Take note. So we have next the elastic potential energy, the energy you have stored in a spring or in your bow and arrow, in your catapult. And whatever has that elasticity has elastic potential energy. Then we have the geothermal energy, which is the energy in the earth. Down there in the earth, do you know it is very hot? It's as hot as 6,000 degrees Celsius. Okay, down there, when you go through the layers of the earth, the crust, the mantle, the outer core, and the inner core. The inner core is as hot as 6,000 degrees Celsius. So as you go down the earth crust, you have the geothermal energy, energy stored in the earth. Okay, then we have the chemical energy, like the one you have in your battery. Okay, beautiful. The energy you have in your food or in your, for example, petrol, that's chemical energy. And then you have the nuclear energy stored in the nuclei of atoms, and which is harnessed to produce what we call the nuclear energy. Okay, so these are the different forms of energy classified under the two types of energy. You may want to run through them. Under the kinetic energies, we have mechanical energy, magnetic energy, electrical energy, sound energy, light energy, and heat energy. Under the potential energy, we have the gravitational potential energy, electrical potential energy, elastic potential energy, geothermal energy, chemical energy, and nuclear energy. Hey, so what next? We now look at how energy is measured. The SI, or the standard unit for measurement of energy, is the joule. Capital J. The joule is the standard unit for measurement of energy. However, there are other units for measuring energy, like your kilowatt hour, your thermal, and your calorie and kilocalorie. These are different units for measuring energy. But remember, the standard unit for measurement of energy is the joule. It's very important. Okay, let's move on now. Now that we talk about being able to have a unit for measurement of energy, but you know that the amount of energy in any system is actually gotten by calculation? Yes, even when we use what device we call the calorimeter, at the end of the day, we still carry out calculation. So we calculate the amount of energy in any system or in any object or in any body. But take note, the unit for measurement of energy is the joule. So it's time to move on. How is energy transferred? What does it mean for energy to be transferred? Look at this ripple on water. You can see the wave, what you call the ripples, moving out. This is energy being transferred. Look at the speaker. You can see the sound wave or the sound energy moving out. This is energy transfer. Look at this pan on fire. Right here you feel the heat. Why? Because its energy is transferred. So what then is energy transfer? It's very simple. Energy transfer is the movement of energy from one point to another. You don't need to memorize, you just have to have a mental picture in your mind whenever you want to define anything. And once you have the picture in your mind, you can define it. Energy transfer is the movement of energy from one point to another. Beautiful. Energy can be transferred by either work or as a form of heat transfer. What we have here with the ripples, the sound wave moving out, this is as a result of work. But what we have here as heat energy transferred is as a result of what you call conduction. Now we have known what energy transfer is. Let us now go over to another aspect of it, energy form transformation. Look at all these here. The light bulb, the electric fan, the spring, the guy ironing, of course your fruit juice. Wow, that's yummy, you know. Let's look. What happens as energy form transformation? Energy can be transformed from one form to another. For example, the light bulb transforms or changes electrical energy to light energy. The electric fan transforms or changes electrical energy to mechanical energy. Mechanical energy is energy in motion, okay? Look at the spring. The spring transforms or changes elastic potential energy to mechanical energy. Okay. Oh, the guy ironing. What happens? Electrical energy is transformed to heat energy. And the fruit juice. Chemical energy is transformed to both heat energy when we eat it and as well mechanical energy. Okay, so now that we know what energy transfer is and what energy transformation is, let us do this exercise. So you will be the one to do this and give me the answer. Look at the pictures closely. A, B, C, D, E. State the energy transformation in each of them. You may want to pause this video at this point, take notes, and do it. It's very important you do this. This is not for formality, it's for you to learn, okay? Don't say, oh, Mr. Matthew, you didn't teach me this, Mr. Matthew. No, that's why it's for you to do. Don't always blame your teachers or rely on your teachers to give you all answers or every answer. It is time you get thinking. If a teacher teaches you to a point, you show that you can think and go further. So look at each of those pictures and provide the answers yourself. Thank you. Remember, this is Maths and Science Clinic Daily for children ages 7 to 14. Feel free to reach us through the WhatsApp contact or visit our social media handles, Facebook and YouTube. It's the same at Maths and Science Clinic Daily. Thank you. Let's move on. What happens to the amount of energy in the universe? Have you ever wondered if we're having more and more energy, or the amount of energy is increasing or decreasing, or it's becoming hotter and hotter, so it means energy is increasing? No, that's not correct. Do you know what? The amount of energy in the universe remains the same. Yeah, we may be having different forms of energy being changed to heat energy, but it doesn't mean that the amount of energy is increasing. No, the amount of energy in the universe remains the same. And there is a very simple law we state when discussing this. This is called the law of conservation of energy. And what does this law state? The law of conservation of energy states that energy can neither be created nor destroyed, but can be changed from one form to another. Please, you may want to say it again. Let's go. One to go. The law of conservation of energy states that energy can neither be created nor destroyed, but can be changed from one form to another. Beautiful. Now we know it. How is energy stored? There are different energy stores. We have the natural stores of energy and the artificial stores of energy. The natural stores of energy include your plant, your water bodies, the earth, and of course your petroleum, which comes from the earth. And then the artificial stores of energy are those stores created by man. This includes your thermos flask or your food flask. You put something out, it remains there, it stores the heat. So we say it's an artificial store of energy. And your battery, we design battery that stores electrical energy in the form of chemical energy. So these are examples of artificial or man-made stores of energy. Now that we know it, let's recap the keywords we've learned so far. It's science time. Energy, kinetic energy, potential energy, energy transfer, energy transformation, we did energy conservation, and energy store. Thank you. Compare your answers again to what you're seeing on the screen. I have to repeat this for you to really be sure of your answers. Okay, I guess you're waiting for me to give you the answers. Well, I'm not gonna give you, it's for you to find out yourself. Good luck. Feel free. If you have your answers, you want to get it across to confirm, feel free. But do it yourself. Thank you. So let's go straight to what we have. Investigating and applying energy transformation. Mariam and Cynthia are trying to design a new power generating system that does not use fuel. Here is their setup. Look at the setup closely. They posit that the machine transforms elastic potential energy to electrical energy, which is transferred for use. Now, here's the question. What is energy? Simple. Energy is the ability to do work. B. State the difference between energy transformation and energy transfer. It's very simple also. Energy transformation is the change of energy from one form to another, while energy transfer is the movement of energy from one point to another, okay? Like when you change from heat energy to light energy, that's energy transformation. But when heat energy flows from one point of the electric ion to another point of electric ion, that's energy transfer, okay? So let's go to C. State completely the energy transformation that takes place in this proposed machine. Oh, beautiful. From the spring. Okay, elastic potential energy is changed to mechanical energy. You can see the spring oscillating and then turning the piston and cylinder. That's mechanical energy. What happens as the piston cylinder turns? You see it turns a disc there. If you go over the video again, you see the disc turning. That's still mechanical energy. But you know what happens? That rotates the DC motor, and the DC motor changes the mechanical energy to electrical energy. So we say from elastic potential energy to mechanical energy down to electrical energy. What does the magnet do in this setup? The magnet provides the magnetic field that keeps the spring oscillating. And then finally, from the cylinder